Alright, calculus, we're going to keep going on with 6.5, and we're going back to particle motion. And I think it's best if I just go back to the answer key and share with you the things to keep in mind, because the derivative of position is equal to velocity, that the antiderivative of velocity would take us back to position. Now, if you remember, I also like writing it as x of b and x of a, but he uses p for position, so it makes sense. So we will be working backwards on some of these problems. Now, here's another thing that we haven't talked about in a while, and that's the difference between net distance and total distance. And there's a quick fix in these problems, because remember, net distance is displacement, which means that sometimes when we move to the left on an object, we will be taking away. So if velocity is below the x-axis, that means we're moving to the left on our position. And what that will do is take away from the total distance traveled. In other words, if I'm below the x-axis, it'll cancel out some of the area that's above the x-axis. So that's why just doing the antiderivative, or the integral from a to b of v of t, will give you the net distance. Well, if you want to figure out total distance traveled, what you can do is just take the absolute value of velocity, because absolute value is always positive. So what it'll do is take any area that's below the x-axis and flip it above, and now it's always positive. And if we're always positive in that instance, then it cannot cancel out with the other area that's above the x-axis. So that's the quick fix on figuring out total distance traveled. And it's very, very useful. And if you want to pause the video and draw a few pictures here, to try and explain why, we want to do the absolute value, I thought it'd be better if I just showed you the picture. So what's in black on this picture is showing the net distance, and what's in red is showing the total distance. And hopefully I did some work trying to explain that. So as I move into the first example, and by the way, he reminds you this is a non-calculator question, we can start to answer some of these premises where we know the velocity and we know certain items. So we know, and I'm going to stick with P just because he does, that P of 4 is equal to 72. So if I were tasked with doing this problem, and I'm asked to find T of 2, T equals 2, what I would do, this is just out of a habit, is do P of 4 plus the integral, because this is my initial condition, from 4 to 2 of v of t dt. That'll figure out what P of 2 is equal to. If you need more of an explanation, I'll just kind of scratch work off to the side. Just a reminder that the integral from 2 to 4, because we usually go from least to greatest, you don't have to, as you can tell I did not in that problem, is equal to P of 4 minus P of 2. Well, if my whole intent is to solve for P of 2, maybe what I will do is just add that to the left side, and then what I can do is subtract this term to the right side. So I'm looking at P of 4 minus the integral from 2 to 4 v of t dt. And you might be sitting there and saying, well, that's different than what you wrote. That's right, it is. But all I have to do is switch these two around, and if you switch those two around, it becomes a minus problem. Not sure why the colors change, but so there you have it. You have two different ways of understanding how to come across this problem. So now we can start to solve this. And we know v of t is this value, and we know P of 4 is equal to 72. Might want to throw in some parentheses in here because you have to do the antiderivative of 3t squared, so add 1 to your exponent. divide by your new exponent. 3 divided by 3 is 1 plus 6t. And we're going from 2 to 4. Kind of running out of room and kind of nervous that they would say that this is a no calculator because those are some scary numbers. But anyway, 4 cubed is 64 plus 24 and then minus, maybe I should put in some parentheses here, plugging in 2 cubed is 8 plus 12. I don't know how scary this really is for you because 8 plus 12 is 20. If you subtract off 24 minus 20, you're at 4, so 64 plus 4 would be 68, and 72 minus 68. Pretty confident that answer should be 4. And maybe his work is slightly different. Yeah, he pretty much explains it the same way. A little bit better. I mean, this looks cleaner than the way I wrote it, but you can pause the video at any point and try to write out your work. Now, I did want to show you the answer key anyway, because what I don't really like about this problem is that the velocity is always positive. So if the velocity is always positive, that means the particle is always moving to the right. Now, you might be sitting there and say, well, if it's always moving to the right, how come we got such a small answer here? Well, remember, at t equals 2, that's further on the left than this. So we should have an answer for 2 that is smaller than 72. Because the velocity is always positive, so the particle is always moving to the right. Since the particle is never changing directions, as I get to the total distance traveled down here, we actually don't have to worry about the absolute value, because this value right here is always positive. So the total distance traveled in this problem will actually also equal the net distance in the problem. So anyway, we pretty much already worked through it. The only thing is now we have to find the antiderivative, which we already did up here. So I feel like I'm just repeating myself now. I don't know how many of you know 7 cubed in your head, but plug in 6 times 7. Now notice that you do want to show the work, because what if I ask you for the antiderivative of, let's say, sine, which is cosine? You should not automatically assume that cosine of 0 is 0. So go ahead and show those steps that when you plug in 0, you do get 0 plus 0. And then from there, you might just need to, I don't know, kind of go through the old school way of doing math, especially if it's a no calculator problem. So pretty difficult here. I thought I could just share the answer key. And at any point, write down your questions or pause the video and bring questions to me. That's a good strategy as I move on to the next problem. Now this one is definitely a calculator active. You can definitely tell because we got some decimals in here. So the biggest thing with a calculator active question is make sure that your calculator is ready, and also pay attention to the directions. So what I would do, this is how I would do the problem, is as soon as I see an equation that looks complicated, is type that into y equals. So just pulling out my calculator, the y equals, I mean, you don't have to clear things out, but I would. And we're looking at 0.5 e to the t power. I'm using x here, which is fine. And then quantity, whoops, better fix that. X minus 2 cubed. And double check that you typed it in correctly, because if you typed this in incorrectly, like I almost did, who cares what else you would have done? You're going to get the wrong answer. So yeah, double check that that's good. So as we get to the first question, if the position of the particle at t equals 1.5 is 2.551, what is the position when t equals 3.5? Now, if you need to go through the whole process of understanding that the integral from 1.5 to 3.5 of v of t dt is equal to v of 3.5 minus, whoops, not v. I'm sticking with the p value that that he gives you, because it's got to be the antiderivative of v, which is p. I'm just not a big fan of this because I'm so used to the textbooks that go ahead and add the p of 1.5 over, and then they can quickly solve. So this is all the work that you need to show, because at that point we're trusting that you're going to your calculator. So let me show you how to type that into your calculator. So once you have that in there, just quit out of that. Go back to type out what p of 1.5 is, and then plus, under the math tool, you have the integral as the 9th option down, and 1.5 to 3.5, and then alpha trace to grab that equation in terms of x, because that was the variable we used. Hit enter, and it'll tell you the exact answer, 18.470. So now we're going to get into total distance traveled. Okay, and we care about from t equals 1 to t equals 5. Now I'm going to over-explain this. So if I go to my graph, I'm going to change my window first of all to be from 1 to 5. And I'm going to hit zoom 0 to fit it in the screen. Well, I don't think this really matters because it's above the x-axis throughout, which probably makes sense. It's always above the x-axis. But in case it was not, if it was below the x-axis at all, what you would want to do for back in your home screen is do the integral again, which is the math 9, from 1 to 5, and then under the math tool, well, there's two ways to get there. You can go over to math, over to num abs, that'll create your absolute value, or, let me quit out of that. Remember, your catalog has everything. Second 0, and the very first option there is abs, and then alpha trace to grab your equation for the velocity dx. So the total distance traveled is that. Let me just play around for a second. Let's get rid of that absolute value real quick. I want to see if it's always moving to the right. No, there's a little part where it's below the x-axis. So notice the net distance would cancel out part of the total distance. So 913.067. But get in the habit of showing your work. Make sure when you do this, you write out what you did. To get that answer. I'm just double checking with the answer key. Yeah. And you don't have to retype out the equation because the equation was defined up here as v of t. It's just basic substitution, so you don't have to do that. And this might be a good place to stop. I don't want to rush through anything else. So I'm sharing the answer key in case you'd rather see his work than mine. So you can hit pause, copy down what you need to, and we'll see you in the next video.